Ever wondered how traffic surveillance systems can detect overspeeding or dangerous lane changes? In this video, we are diving into an AI-powered dashboard built with Python, YOLO v3, and Jupyter widgets that actually detects real traffic violations from video footage. What we are building? We build an interactive dashboard that takes video input, detects vehicles in real time, and identifies traffic anomalies like overspeeding or improper lane changes with visual feedback and a report. The tech stack which we used in this Kaggle project was under the hood we are using YOLO v3 for vehicle detection, OpenCV for video processing, ipywidgets for building the dashboard UI, and all running inside a Kaggle notebook. Ask my friend Abid to continue with how the YOLO v3 model works in this application of computer vision. So you can continue, Abid.
Thanks, Supravo. The project we target analyzes the traffic video frames to detect overspeeding and lane change violations using YOLO v3 and AI summarization using Gemini. Now, let's dive into the logic behind this application. First, we will import the essential libraries which are NumPy, Pandas, CV2OS. After that, we will loop over all the available files in the Kaggle input directory. Then we will set the video path and the output folder where the video will be loaded. After loading the video, we will read and save the frames. The frames are saved per second, so the count is incremented by 1 when it is divisible by the fps. After that, we will load the YOLO v3 model. The it loads the YOLO v3 weights and the config for object detection. Then the vehicle IDs where 2, 3, 5, 7 correspond to car, motorcycle, bus and truck respectively. For the object detection function, it converts the image to a YOLO compatible blob and performs a forward pass through the network to get the detections. After that, we extract the vehicle positions and draw boxes. For each detection, it is filtered by confidence threshold, which we have taken greater than 0.4, and it is checked whether a class is a vehicle, and we calculate the bounding box coordinates and draw green rectangles on the original frame for each detected vehicle, and at last return a list of vehicle positions for further analysis. After that, we read up to 10 saved frames which are detected using in which vehicles are detected using YOLO v3. The detected vehicles have green bounding boxes around them, and and each frame is displayed using Matplotlib. After that, in this code, we initialize the list and the dictionaries. The list store events for letter summary, example overspeeding incidents, left or right lane changes, and dictionaries are used to track vehicle states over time like speed, position history, etc. We loop through the frame pairs. For every consecutive pair of frames, frame I-1 and frame I, we detect the vehicles and compare them. And for vehicle matching, for every vehicle in the current frame, it tries to match it with a previously detected vehicle based on proximity. If no match is found, a new vehicle is assigned. Here, if there is a 90 pixels gap between between the present and the previous frame of a vehicle, then we will assign a different vehicle ID to it. After that, we assign and after that, for each vehicle id in the vehicles to in the present frame, we assign min list is equal to float infinite. After comparing the previous center with the present center, we find out the mean this whether it is less than infinite, and if it is less than, then we will append it in the speeds list. In the speed threshold, speed is equal to mean this, then we will append it. The speed is calculated as the pixel distance moved between frames. After that, for overspeeding detection, if average speed is the list which contains the speeds of over 3 frames, is if it is and is divided by the length, that is 3. If it is greater than the speed threshold, that is 175 pixels per second, it is flagged as overspeeding. A red bounding box and the speed level is added to the frame. And similarly, for the lane change detection, if the average speed is greater than 90 pixels per second and the lane shift total is greater than lane shift threshold, that is the horizontal distance across the recent positions is more than the threshold, then we will flag it as a lane change, and a cyan box and a label will show the direction whether the lane change is left or right. After that, we will print the summary where it displays the unique vehicles, overspeeding incidents, and the lane changes. Now we visually inspect up to 10 annotated frames where overspeeding vehicles were detected. We see that it loops over the first 10 overspeeding incidents and builds the path to the saved annotated image and ensures the file exists before displaying it, and displays the image with the vehicle ID and the frame name as the title. After that, similarly, we have applied this for lane change incidents and also for incidents where both overspeeding and lane change occurred. After that, we have integrated with Google GenAI Gemini to generate traffic behavior analysis from the surveillance data. In the Gemini insights, I both event frames where they have occurred are also being shown. So from here we can get the clear summary statistics from our detections. Real world interpretations like speed conversion, pixel per second to meter per second, and thus we will get the insights. We have written prompts, and the Gemini will likely respond with interpretation of how serious the overspeeding situation is based on the threshold, which we have given as 7% over here. Insights into the left or right lane changes, whether both violations together are common or rare, and will give the commentary on the discipline or recklessness or the congestion, and also will suggest us and also will ask what can be provided more to give better suggestions. And after getting this, we can see the prompt which have been given as the insight, and after that we will clean up the frames folder so that we can use it further for our other use cases. So from here on, I take Suprabho to carry forward.
So we use the library ipywidgets. Here we define the file path and the output frames directory where it will be stored. The following variables, which are the global states, frame files, output folder, overspeeding incidents, these are all the default global variables for our project. In the try catch block, we detected all the error handling, and in the widgets we developed a upload video button which also accepts the videos from the user directly from the file manager or file explorer. The detect vehicles and detect anomalies, these are the two main window buttons in the main window. These two actually responds to the buttons and gives the number of detected vehicles, and also gives us a information regarding how what are the anomalies are detected inside the video uploaded or footage also, you can say. There are multiple analysis buttons which I have developed collaboratively with my friend Abir. First, there is a summary button which gives us just a small summary about all the incidents that happened in that footage. There was another button which is known as overspeed button, which also responds which vehicles have detected for overspeeding. Lane change button and both buttons actually where the vehicles have detected both overspeeding and lane change simultaneously. That is for the both button. And in the insights button, we get the response from the Gemini API key using the Gemini 2.5 Pro model. And in the end, we have created a submenu for those buttons. And these functions, which are already been discussed above by my friend Avi Shah, so it's nothing more to discuss there. These are all the same functionalities which are discussed above. But all those callback functions are used here as a callback actually for the UI layout. There are two widgets for the output panel. There are multiple tabs. First for the anomaly detection, and second is the results, where all the results are being shown for any button in the results tab. And these are nothing but blind buttons for the respective event handlers. There is a function called extract frames for extracting the frames from the input directory, which is our, for example, our CCTV footage from the traffic signal, which extracts the frames by frame manner. And in the detect vehicles, it actually detects the vehicles from each frame using the rectangular green color bounding box for detecting the vehicles. This function actually gives us the uh, coordinates, x and y coordinates in the pixel array. In the DDA is actually a double dimensional array in pixel. It gives us the coordinates where it is actually located. It's a spatial coordinate, obviously. It gives us the coordinates in the space. In the detect vehicles button clicked, this is actually nothing but the response from which the button will be clicked. Here, when I click the detect vehicles button, all these functionalities will be working behind the Kaggle notebook. These are all the same functionalities which are discussed above by my friend Abhi. Let's go to the conclusion. Let's wrap it up. What we have told to our audience. So this is the actually the UI, or user experience or user design we have built for our Kaggle project. It's not a separate app or website. It's actually a widget that is already developed inside the Kaggle environment. Here he uploaded the video and now it's detecting the vehicles. My friend Abir is, so see there is a growing bar in blue, in young blue or clear, light blue color. What you can say? It's detecting all the frames. Yes, it's detecting it, and it will be shown here. Yes, see all the vehicles are detected. All the vehicles, even in the vehicles which are parked. Let's go to the next dating anomalies. Yes, here it will detect the anomalies. It will take some time as it will also generate some statistical data and inference from the data. It will take some time. It will also generate some pie charts, bar graphs for our detecting anomalies function. Yes, this is the bar graph which I have calculated. See, we can see that overspeeding is minimal, or I can say it's negligible. No overspeeding, but there are multiple lane changes, and as well as there is a graph for the left and right changes respectively. So this is the inference we can get from the detect anomaly button. Let's go to the analysis options. This is the summary which we'll get from the, actually it is actually getting this data actually from the these buttons, detect vehicles and detect anomalies buttons. So summary gives us a overall response. Yes, there is the pie chart. See there, the overspeeding there is 0.0% overspeeding. Overspeeding incidence 0. Lane changes detected is 11. Left change, left lane change 2. And right ranges, so the sum is 11. Okay. Total unique vehicles is 108. As there is no overspeeding, so no image also detected, so no yeah, no marking on the graph. In this CCTV footage, there are multiple lane changes. So these are the plots. Even you can see in the images. This car is actually marching to the junction, so it's considered as a lane change while marching as a junction. Let's go to the next functionality. Both violations, yes, this is one which is where the both are detected, both overspeeding and while and lane changes are detected by any vehicle. But here in this case, in this footage, we see there is nothing. No one has done this. Yes, as it is an and condition, so it must be that there must be overspeeding as well as there should be lane changes. So no one has done that. There are only lane changes, no overspeeding, so it is 0. Yes. Let's continue with the Gemini insight and wrap it up. Let's fast. So these are the all the insights we can get from the Gemini, right? So yes. So so road safety is a huge concern while worldwide, and AI-powered surveillance can help reduce accidents by spotting risky behavior and save lives, as well as in real time enforcing traffic laws more effectively. This project is just a starting point. Imagine integrating it with like live CCTV, alert systems, or even automated law enforcement tools. It will be a boom. So if you enjoyed this project, don't forget to like, subscribe, and drop a comment. Want to see lane departure warnings or number plate recognition? Let me know. I might just build it next. Thanks. Bye.